Like the branches of a tree, bones are sturdy organs that provide the body with support. But in case of an accident or fall, even the strongest bone can snap like a twig. Orthopedic surgeon Charles Milgram encounters many such fractures.
Here is an X-ray of a hip of someone who was hurt in a car accident. He has a lateral fracture of the femur bone. And the surgeon's solution was to repair it by inserting a rod inside the bone and locking it with screws.
However, before any rod can be inserted, the two fractured parts have to be aligned manually. This is no easy task. The bone is hidden behind flesh and muscle. To avoid cutting the patient's leg open, Professor Milgram relies on a fluoroscope, a machine that takes continuous X-rays. Every time he moves the bone fragments, he takes a new X-ray picture until finally he sees that the bone is correctly aligned. It is now time to insert the rod. Milgram tries to estimate the accurate rod size to fit the specific bone, choosing from several possible options. He then drills a small hole in the patient's upper thigh and begins insertion. This again requires taking continuous X-ray images to make sure the rod is placed correctly in the long, narrow canal. Thus, each operation requires taking several hundred X-ray pictures, exposing Milgram and other surgeons to unhealthy cumulative radiation. And since this method involves a lot of guesswork, it could lead to errors and complications during and after surgery. In this example, the healthy leg is clearly longer than the fractured leg, indicating that the rod was not inserted correctly. The patient had to undergo a second round of surgery. Yet this year, Milgram developed an original solution for these difficulties, along with computer scientist Leo Yoskovich and his colleague Ariel Simkin of the Hebrew University in Jerusalem, Israel. They brought their invention to the Hadassah Medical Center, where they are now testing its prototype. The system simulates one-to-one what happens inside the patient's leg as the doctor tries to align the fractured bone during surgery. For demonstration purposes, the broken bone is hidden behind a sheet which obscures it from Milgram's viewpoint. But he now has in front of him a computer screen with a three-dimensional real-time picture of the bone he is trying to repair. As he gently moves the fractured parts toward each other, the picture on the screen moves in perfect correlation with his movements. Thus, the computer patiently guides him until precise alignment is achieved. As can be seen, insertion of the rod is now just a piece of cake. How does this system work? A series of cross-section pictures of the broken bone is created using just a few X-rays taken before the operation. These are turned into a three-dimensional model which allows system operators to see the bone from all angles. It also enables them to give the doctor precise information about the optimal rod size. During the operation itself, the system requires inserting small optical sensors into the broken bone. Once the actual process begins, every movement of the bone moves the sensors. Their movement is tracked optically by a camera, which transfers the information into the computer. The computer, in turn, translates it to the three-dimensional model stored in its memory and adjusts it accordingly until perfect alignment. Thanks to hot science from Israel, Milgram and other surgeons will be able to offer future patients a safe and easy operating method, a far cry from the days of blind second-guessing and hundreds of X-ray images.